Welcome to Lesson 4.1 of the Pearson video series. The first section in Chapter 4 refers us back to what we know about rigid motions. When we talk about congruence, we are referring to figures that can be mapped onto each other with a rigid motion. That means the figures have the same angle measures and the same side lengths. A congruence transformation is another name for a rigid motion. Okay. If we want to verify congruence, that is, if we want to determine if angle GHJ is congruent to triangle KLM, we can see if there is a rigid motion that will map the first onto the second. Let's draw a couple of reflection lines. The horizontal line is going to go right through points G and K. That'll place it between the two figures horizontally. The vertical line, if placed between J and M, is going to be right about here. 1 unit away from each one of them. Okay, so what do you think this line right here is? If you said y equals -2, you are absolutely right. What do you think the vertical line is? Okay, I'm sure you know that that line is x equals 1. Okay, so let's take a look and see what happens if we reflect triangle GHJ over y equals -2. The G is not going to move. H is going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So right here. And J is going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that one's going to be right here. Okay, let's go ahead and connect those points. We've got that one. We've got that one. And we'll draw this one. Okay, this looks pretty close. And we've got this right in between these two, so that looks good also. So if we take a look at where this ends up when we reflect it over x equals 1, this point is going to go over 1 and over another one. This one's going to go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And the last one, point G, is going to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it appears that we could map triangle GHJ to triangle KLM with a reflection over y equals -2 and x equals 1. Okay, so let's think about how we would write that. Keeping in mind that that's a composition, and compositions go right to left, we would start with the second one, which is a reflection over x equals 1, and then our composition symbol, and a reflection over y equals -2. And we know that we did the reflection over y equals -2 first, and then we did the reflection of x equals 1. Okay, what is another composition of rigid motions that maps triangle GHJ to KLM? Okay, so let's take a look at another graph. Let's make it a little bit bigger so that we can have a little more room to space it out. Okay, if we are looking at this one right here, we could rotate GHJ around 180 degrees and then see how it compares to triangle KLM. Let's do that. So we're going to rotate it around point G because G and K are in the same spot. Okay, so if we do that, then 1, 2, 3, 4, 5 units up and 2 units to the right is our H. So let's go 1, 2, 3, 4, 5 units down and 2 units to the left. Okay, and then from this one, we're going to go 1, 2, 3, 4, 5 units to the right. So we'll go 1, 2, 3, 4, 5 units to the left. Okay, now we're going to go ahead and draw this. We'll connect these points right here and right right here. Okay, now it looks like we have two triangles with the same orientation. So we have rotated it 180 degrees about point G, and now we can slide it over. It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 points. Let's see if it works for the other two. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so it looks like 16 units to the right. So we are talking about a rotation about point G and a translation of 16 units. So that means we're going to start out with our translation first. So translation, 16 units to the right is positive, and we're not going up or down. And then our rotation, so that's a lowercase r, of 180 degrees about point G. Okay, so there are two different transformations that we could use in order to map the first triangle onto the second one and thereby verify its congruence. Okay, now identifying congruent figures. So if we want to identify congruent figures, we can verify that they have the same side lengths. Okay, so looking at these two right here, if, let's see, this from B to C, it goes over 3 and up 1, so over 3 and up 1. From A to B, it goes 1, 2, 3, 4, up 4 and over 1. This one goes 1, 2, 3, 4, and over 1. So it looks like those two are going to be the same because we have the same side lengths. So in order to write a congruent statement, we're going to say triangle ABC is congruent to triangle JKL. All right, and anytime you have two triangles that are congruent, you're going to have something like this. This is called a congruent statement, and we'll be writing a lot of these. Okay, let's take a look at our last example. Okay, so this last example, we want to look here and see if, first of all, if A, B, C, D, and E, and J, K, L, M, N are congruent. Okay, so that's this one and this one. So let's see, it looks like we have okay, let's see. We have 1, 2, 3 units, 1, 2, 3 units. Okay, those are the same. So let's go ahead and mark those the same. And then we have a line right here. It's down 1 and over 2. And so that would be this one, but this one is over 2 and up 2, not the same. Okay, so these two are not going to be the same. We have two lines that are not equivalent. So we're going to say no, resoundingly. And then our symbol for not congruent, there's congruent, not congruent looks like that. Okay, let's check the next two. We want to check this one and this one. Okay, so we have 3 units and 3 units. We have down 3 and over 1, down 3 and over 1. We have down 2 and over 3, and down 2 and over 2. That one is also not going to work. All right, so now let's check this one. Okay, so we've got 3 and 3, that works. We've got up 3 and over 1, so those two are going to be the same. We have up 4 and over 1, up 4 and over 1, those two are going to be the same. We have down 1 and over 2, down 1 and over 2, those two are going to be the same. And then finally we have over 3 and up 2, over 3 and up 2. And those two sides are going to be the same. So we can say that these two are congruent. If we wanted to figure out what rigid motions, we could probably flip A, B, C, D, E over the x-axis, and that would put it, let's see, here. Yeah. And then it's a simple slide from there. So it looks like a reflection over the x-axis. So a reflection over the x-axis and a slide 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the left. So we're talking about negative 10, 0. So if we wanted to write that, we would write it as a translation of negative 10, 0 in a composition with a reflection over the x-axis, knowing that we always work from right to left, and so we would start with our reflection and then do our translation. And that means that these two figures are indeed congruent. All right, last thing we're going to take a look at. Okay, you are going to pause the video and eyeball these figures and see if you think they're congruent or not. Now keep in mind they could be congruent maybe with a reflection or a rotation or some other rigid motion. So you want to decide whether or not you think they are congruent, and you're going to circle either yes or no on your buttons over here. So I want you to pause the video, go ahead and do that, and then when you have it all done, then check your answers. All right, let's see how you did. The first one is going to be yes. If we reflected this one over that line, then we would have the same figure. So those two objects are congruent. This one is going to be no. Notice the thickness from here to here and from here to here is different, so there's no rigid motion that's going to map those onto each other. This one is probably the hardest one, and this one is yes. This one with a rotation and a reflection, with a rotation and a reflection, you could map the first figure onto the second one. Let's see, we said this one was a reflection. Okay, and finally the last one. The last one is also yes. And hopefully you noticed that a rotation, 90 degrees, either way, a rotation of 90 degrees would map the first figure onto the second one. See how easy that is? Okay, you'll be working on a Pearson assignment that goes right along with these. See you later.